guys, this is the shell program that I wrote for our systems programming class this past semester. Let's get right into it. I can clean my exec file, make the exec file, and then run the program called shell. So this runs a program normally. We can do, or the prompt is as other Linux prompts would be, typical current working directory here, and they also added the current process ID. We can echo commands, for example. We can list the directories. Now this test directory I have here, we can cd into that. ls its contents. Now we have a text file called hello text. Let's remove it. And we can also use one of our logical operator commands, and, which executes the second command if and only if the first command was successful. So let's remove hello.txt and then create a new file, new.txt. As we can see, they were both executed. And something to note here is that these process IDs are all parent processes. These are the same. But every subroutine is executed by a new process. So echo hi is executed by this process right here, so on and so forth. But we can see that we have new.txt. Let's vim into that file, and obviously nothing is there. Let's add something. Hello, this is Ashwin. Okay, and then we can leave. Let's go back to our current working directory, and I can show you some other built-in commands. One is the OR logical operator, which only executes the second command if the first command was unsuccessful. As we see, the first command was, or the second command was not executed, but if we were to do this, then the second command would execute. Last is the semicolon separator, which behaves exactly as Linux's built-in semicolon separator. We can also take a look at our history with all the commands we've run inside this process ID. If we want to run one of those commands, we just put number, and then let's say we want to ls number 4. Great. Let's say we want to clear. That looks a lot nicer, and then we can look at our history again, and we can see that those two commands were appended toward the end of the history. Let's exit back to our actual Linux shell, and we can run this exec file with a history command, and this we call h.text. It'll populate this h.text file with all of the commands we use: clear, ls, cd into our test directory, cd back out of it, echo hi, sleep for 2 seconds, whatever. We can vim into our h.text file, and as we see, all of these commands are stored, even this last vim command. Escape that. If we exit out of my shell into Linux and then vim into that h.text file, we will see the same thing. So yeah, that's essentially what the shell program is. Yeah, I learned a lot about forking, creating different processes that share memory, and ensuring that each process is running not concurrently, but running independent of the other process, and sometimes concurrently depending on the situation. But yeah, thanks for watching.